Hi friends, welcome to VK Lectures. In this lecture, we are discussing the 35 and 36 question from Kset 2018 Physics question paper.
Particle of mass m and charge E moves in an electromagnetic field described by a scalar potential phi and the vector potential A. If c is the speed of light in vacuum, the momentum conjugate. The momentum conjugate of r position. So we have the Lagrangian of charged particle in electric and magnetic field or electromagnetic field is given by L is equal to half mv squared minus q into phi plus q into v dot a. Now this v is velocity of the charged particle. Now how to find out the momentum conjugate? It is nothing but P is equal to dou L divided by dou V, where V is the velocity. Okay, now that will be equal to mv, this term get vanished, plus qa. Alright, mv plus qa. Now since this is charge equal to E, you can replace this q by E. So your momentum conjugate P is equal to mv plus Ea. Now here you do not have any option corresponding to this answer, but you can give mv Ea by C. Now there shouldn't be C here, there is maybe a mistake, typing mistake. Now if there is C, this question is dimensionally incorrect if you put C. Now dimension of vector potential A is m L t to the power minus 1 q to the power minus 1. And what is momentum dimension? Momentum dimension is nothing but m L t to the power minus 1. Okay, so E into A means q times m L t to the power minus 1 q to the power minus 1. Q to the power minus 1 and q get cancelled, ml t to the power minus 1 ml t to the power. So this is momentum. So this mv and A by C are two different dimensions, so there is no need of C here, it is a mistake. So but the correct option is mv plus Ea, where A is the vector potential and V is the velocity of the charged particle.
Question number 36. If a light is incident at a Brewster angle on a glass slab, it results in, now assume that this is the incident light and this is the glass slab, the interface. This is the air medium and this is the glass. Okay, this is the glass slab. Now when if assume that this is the Brewster angle, then it has a plane polarized light in the reflection. So this is the reflection, and here the electric field will be plane polarized. Okay, now to support this, so the option is option A, and to support this we have few statements. That is, when light is incident at Brewster angle on glass slab, it results in production of plane polarized light. So plane polarized light in reflection. Okay, so the reflected light becomes completely plane polarized. So this is another statement which says the same thing, and here is a small tail to end to this. electric field vector. So this is the electric field vector, and perpendicular to the plane of incidence. So if you consider this as the plane of incidence, then all these lines, actually we have to draw it in like this, perpendicular. That means this into the screen, it's going into the screen, not actually the like this, it's into the screen, green line is into the screen. Okay, now field vector perpendicular to the plane of incidence. Now the reflected light wave undergo selective polarization. Now what about this, meaning the selective polarization is nothing but it focuses on electric field vector of the reflected light perpendicular. So magnetic field vector is not considered here, and electric field oscillates in a plane. Oscillates in a plane means it goes like this in a plane. You can catch it in a plane. In the otherwise it is moving like this. It has a phase change. Okay, it's like a revolving kind of a thing. But now here in the case of polarized light, it will be in the plane. You can catch it in a plane. Okay, so 36 option A. Questions from quantum mechanics are 37 and 38 regarding the uncertainty and the hydrogen atom in the 38th question. Please try to get the answer for this, and we will be trying to solve this problem in the next